Algebra 2 Homework 13.3. What does the value of f of x equals 1 plus 1 over x to the x power approach as x increases without bound? Probably first thing is, let's see here. You might want to go to www.desmos.com. Well, I'm not writing very well at all, am I? www.desmos.com and then /calculator and get their graphing calculator. That'll help you with these. All right, so back to the question. What does the value of f of x, 1 plus 1 over x to the x power approach as x increases without bound? Let's try that. So let's go to graph, and we got open parenthesis 1 plus divide 1 over x to the x power. So what does that approach? Let's see, 1, 2, almost 3, so we're ready. Let's see here. Let's try this. Let's try the letter E. All right. So E, let's try that. It approaches the letter E, okay, or the number E. And then I know you're thinking, well, what is the number E? Well, let's see. It's 2.71828, and it's one of those irrational numbers like pi. It just keeps on going and going and going. But there it is. So what does the value as x approaches positive infinity, f of x approaches E. And the same thing as it approaches negative infinity. You saw that as well. It approaches E. So that's number one. Number two, identify the key attributes of f of x equals e to the x, including the domain and range in set notation, the end behavior, and all intercepts. Okay, well, let's graph it. Let's graph it. On, new document, no, graphs, and then e to the x power. And, well, look here. It goes through 1. Let's see, Control T. It goes through 0, 1. It goes through 1 on the y-axis, all right. And then 1, and it's 2.718, or E, okay. And then it just goes on and on and on up. Okay, so let's take a look at it. As x approaches negative infinity, f of x approaches 0. As x gets out here and approaches positive infinity, f of x approaches positive infinity. And so let's see here. Domain. The domain will be x such that x is all real numbers. All right. The range is going to be like it has been in the past. We're going to have y such that y is greater than 0, whatever k is, okay? Oh, we haven't done that part yet. Well, let's do that real quick. G of x equals a times e to the x minus h plus k. So what does a do? What does a do? Let's see. Vertical stretch or compression, and reflect over the x-axis if it is negative. H, horizontal translation, left or right, and then K, vertical translation, up or down. Okay, so we got the domain and range, and let's see the end behavior. All right, as x approaches negative infinity, f of x approaches 0, and we can look on here and see that. See, as it further it gets out here, the closer it gets to 0. As x approaches positive infinity, f of x approaches positive infinity. And again, we can see that because it's going up. All right, good. And so we got the end behavior. What about intercepts? Well, it only crosses the y-intercept at 1. Okay, crosses y-intercept at y equals 1, does not cross x-intercept. Now this is for the parent function. Okay, this is for the parent function, which that's the parent function. This is if it's been transformed. Okay, and it would be a real good idea to put that in your notes. Okay, on the 3x5 card for the test. Number 3. Predict the effect of the parameters h, k, or a on the graph of the parent function f of x equals e to the x. Identify any changes in the domain, range, or end behavior. All right, in this particular case here, h equals 1/2. Okay, so we're going to have a horizontal translation, right 1/2 unit. Okay, what about the change on the domain? No change on domain or range, or actually the end behavior either. No change on domain, range, or end behavior. All right, let's take a look at number 2 here. This happens to be in the k spot, so k equals -5/2. That's going to give us a vertical translation. Down 5/2 units. All right. Domain will stay the same. Domain will be x such that x is all real numbers. The range is going to change. And that's going to be y such that since a is positive, it'll be y is greater than -5/2. What about the end behavior? As x approaches positive infinity, f of x approaches positive infinity. Now, what about here? What about, see, because now you have a new horizontal asymptote. Let me show you. Well, as x approaches negative infinity, f of x approaches negative 5/2. Okay, and I can show you that real quick. Let's see here. So tab, get it off of that, tab, and we'll just put in minus control divide 5/2, and you can see it now here at 5/2. Tab, negative 5/2, and you can see it approaches that instead of 0 now. All right, so the range is changed. The range changed, and the end behavior changed. Number five. This time we have a equals negative 1/4. So we're going to have a vertical compression by a factor of 1/4 of 1/4, and reflect over the x-axis. All right, excellent, excellent. And let's see, what about the domain? What is the domain going to be? X such that x is all real numbers. And the range, does the range change? It does. It's going to be y such that y. We have a negative a, so it's going to be less than 0. And since k is 0, it will stay less than 0. What about the domain and range? What about the end behavior? As x approaches positive infinity, what does f of x do? Approaches negative infinity, because now it looks like this. It's going down instead of up. All right. And as x approaches negative infinity, f of x approaches 0. All right. And let's just try that. Let's see how close we came to that. Tab, we'll go up here. And let's see here. We'll get rid of that. We don't need that. And then we'll go up here and we'll get rid of, oh, we don't want to do that. Let's see here. We'll put in negative and then control divide 1/4. And let's put a times in there. Okay, see how I did it? All right, good deal. So as it approaches negative infinity 0, as it approaches positive infinity, negative infinity. Looking good. Number 6, your turn. All right, you do it. And feel free to stop the video while you do that. Okay. Number 7, the graph of f of x equals c times e to the x power crosses the y-axis at 0c, where c is some constant. Where does a graph of g of x equal f of x minus d cross the y? You know, let's try that. Let's try that. We'll go in here on new document, no, and graphs, and we'll put 2 times e to the x. What does that do? Oh, it doesn't go through 1 anymore. It goes through 2. Okay. Well, I wonder, tab, if you put some number like 3 in there. Let's see. Yeah, let's change that. Let's change that to a 3. All right. Now it goes through 3. All right. So okay. So that's true. It crosses like that. Now, what about this f of x minus d? Where's it going to cross through there? All right, let's try that. Let's see, tab. Oh, tab. And let's take that out. And we're going to put in minus 3. Well, okay, so now it crosses through there. Crosses through -2. Okay, instead of 1. So that brought it down 3 and it crossed it. Okay. I wonder, tab, I wonder, let's just spitball in here. 3 times and then C. Oh, well, that put it back through 0. Huh. So you tell me, this is too cool. We got to try. We got to try this again. What if this went through, we put a 4 in there? What would happen then? Oh, it would go through -1. Okay, -1. Well, let's see, 3. Oh, are you seeing a pattern yet? So where would it cross? It would cross at 0 and then C minus D. Isn't that cool? All right. Let's see here, number 8. Given the function a times, identify the reference points and use them to draw the graph. State the domain and range and set notation. So we got to remember to do the domain and range. I'm not sure I'm going to remember without somebody helping me, but we'll see. We'll see here. Let me get me some real estate. And I got A equals, well, there's nothing there, so we'll say it's 1. H equals, and that's 1 as well. And K equals 2. All right. Cool so far? Now, what do I know? What do I know? Well, let's see here. We're going to have some point H and then A plus K. All right. And what is it? H is 1. And then A plus K, that's going to be 1 plus 2. That's 3. So I have a point at 1, 3. There's one point right there. Now, my second point is going to be 1 plus H and then A times E plus K. So let's try that. 1 plus 1, that's going to be 2. A, 1 times E, so that's going to be E plus 2. Well, E is, remember, E is 2.71. So that's going to be approximately 2 and 4.71. 718, however you want to say it. So let's see here, 2 and then 4.718, that's going to be right about there. Now, did we get a new asymptote? Did we get a new horizontal asymptote? I'm not sure. Let's try. Let's see. On, new document, no, graphs, and then what was our equation here? We had E, and that was x minus 1 plus 2. Oh, it looks like we get a right here. I'm just, we'll just try. Huh, look at there. So it's going to approach 2. Okay, it's going to approach 2. So we're going to have something that goes along the lines like this. And there we go. We have drawn our graph. Now, what about number 9 here? Let's try number 9. I got to get me some writing room here. What do we got? So A equals, it looks like -1. H equals, and we got +1 here, so that's going to be -1. And we got K, well, that's boring. -1, -1, -1. Wonder what's going to happen here. All right, let's see here. We got our first point is H and A plus K, and that's going to be H is -1, and then -1 plus -1 is -2. So I've got -1, -2. That's right there. All right. And then my second point is H plus 1 and A times E plus K. And that's going to be, well, -1 plus 1 is 0. And then -E minus 1. Okay, and so that's going to be approximately 0, and it's -2.71, so -3.718. So 0 and -3.71, so that's going to look something like that. And I'm guessing our graph is going to look something like this right here. All right. You know, I did forget something. Domain. What is the domain? The domain is X such that all real numbers, and the range is Y such that Y, A is positive, greater than 2. All right. Now, let's see here. Let's see. Oh, let's do it here. What's the domain? All right. X such that X is all real numbers. And the range is going to be Y such that Y, we got -1, that's going to be less than, and K is -1. All right, X, so that's 9. 10, oh, 10 is your turn. 11 is your turn. All right, you do them, and then we'll check them in class. 12, oh, yeah, now it's fun. Write the function whose graph is shown. State the domain and range in set notation. Okay, so how are we going to do this? Well, we're just going to reverse what we've been doing. All right, so let's take a look here. We need to know what A is, what H is, and what K is. All right, just looking at the graph, I see Y equals 3 here. That's my horizontal asymptote. So my K is 3. All right, and I also know that I have H and then A plus K. All right, and that happens to be -2 and 8. Well, that tells me that H is -2. Remember, that's the one that's closest to the asymptote. And I know that A plus K equals 8. Well, K is 3. We got that already, so we subtract 3, and we get A is 5. So our equation is going to be G of X equals 5 times E X plus 2 plus 3. I wonder if that's right. Let's check it out. New document. No. Graphs. And then I have 5 times E, and that's going to be X plus 2, and then plus 3. And there it is. Well, that looks pretty good. Does that go through those parts? I needed to go through what? Negative 2, 8 and negative 1 and 5. So I needed to, let's see here. I needed to go through negative 1, negative 2 and 8. Let's see. Control T, negative 2, negative 2 and 8. And then what was the other one? Negative 1 and 5 times 5e plus 3. Is that what it said? 5e plus 3. Well, let's see here. 5 times e plus 3. 16.59. 16.59. There we go. We got a winner. All right. Now let's try 13. 13 looks like fun. And I didn't do this. I didn't do the domain and range. I did not. So let's go back here. Domain is x such that x is all real numbers, and the range is y such that y is greater than 3. And that is a y, not an x. That's poor penmanship. Fix that for you. All right, excellent. So let's go over here and try number 13. What is A? What is H? And what is K? Well, I'm looking, I got right here, so K is 2. H, I got right here, that's 4. And then I got A plus K equals negative 4. And I already know that K is 2, right? So I subtract 2. A is negative 6. Negative 6. So let's try that. Let's try that. On new document, no graph. And I got negative 6 times E, and that's X minus 4 plus 2. And I never did write all that out, did I? So G of X equals negative 6 E X minus H X minus 4 plus 2. Now let's try that. Let's press the old enter button. Does that look like it? It does. It kind of looks like it. Let's see here. So we got 4, negative 4, control T, 4, negative 4. And then what's the other one? What's the other one? 5. Okay, 5. We've got, what is it? Negative 6E, negative 6 times E, and then it was plus 2, plus 2, plus 2. I should get negative 14.3 and negative 14.3 and negative 14.3. Excellent. I like it when it works. So there you go. What's the domain and range? Domain is X such that X is all real numbers. What is the range? I'll let you fill that out. Y such that Y is, what is it? All right, good. What about, oh yes, a word problem. Well, Mr. Carpenter, we can't do word problems at home. We sure can. Watch this. Let me show you. Let's see, it says determine the growth rate or decay rate of the function. Well, we're going to solve it using the graphing calculator, and then we're going to determine that. All right, so we got this. Number 14, a radioisotope used to image the skeleton and the heart muscle has a half-life of about 6 hours. All right, use the decay. Oh, so we got an N sub T equals N sub 0 E, and that's negative 0.1155 t, where n sub is the initial amount, and then and t is the time in hours to turn. How many? 250 milligrams. So we're going to take out this n sub 0, and we're going to put 250 in there. And we want to know how it decays, how long? 16. So we're going to take that and we're going to put 16 in there. All right. So we look like we got some good stuff here. All right. So on new document, no graphs. I'm going to do the right side first. I got 250 times E, and that was negative 0.1155. I can't use T, I have to use X. And it's going to graph like that. Whoa, where'd it go? Tab. Let's try 16. Uh-oh, that one just appeared too. So I'm going to menu 4, and I'm going to, oh, there it is. Escape. Menu 6, 4, 23.8. So I'm going to say, let's see here, how many hours to answer the question is, it takes 23.8 hours to decay to 16 milligrams. All right. Now, the second part was determine the growth rate or decay rate. Well, this is going down, right? Because it started out at 250 and it got down to 16, so it's going down. So we're going to do 1 minus R equals E to the T. Now, in the case here, I think the T was negative 0.1155. Okay, so 1 minus R. Well, let's do a little arithmetic here. We'll subtract 1 from both sides. We got R equals, and that's going to be negative 1 plus E to negative 0.1155. And then we're going to multiply by negative 1. So we get R equals 1 minus E to the negative 0.1155. What is that? Let's see here. Let's go to our calculator. 1 minus E to the negative 0.1155. And that's going to give me 0.1091. 0.1091 or 10.91% decay rate. All right, that's the decay rate. Good job. Let's try number 50. Oh, the George River herd of caribou in Canada was estimated to be about 4,700 in 1954. 4,700 in 1954. And grew it at an exponential rate to about 472,000 in 1984. So we're going to use P of T equals P sub 0 E 0.154 T, where P sub 0 is the initial population and T is the time in years after 1954. And P of T is the population at time T to determine how many years after 1984 the herd reached 25 million. So we're going to put 25 million here. 25, 1, 2, 3, 1, 2, 3 equals, and here we're going to put 4,700 times E. All right. That would be some big numbers and might be hard to find. So I'm going to divide both sides by 4,700. All right, 4,700. And that's going to give me E to the 0.154 T. And let's see, let's go in here and 25, 1, 2, 3, 1, 2, 3, divide 4,700. Don't do that. 5319.15. 5319.15. I don't know what caused. I don't know what caused it to do that. 15. Is that right? 5319. All right, good. Now let's graph it. All right, and on new document, no, and graphs. So our first graph is going to be E 0.154x. Is that right? 0.154x. All right. And we'll press enter. And then we're going to tab, and we got 5319.15. 5319.15. Check that. All right, press enter. You know, it might take a while to find that. What if I did menu 4, 4, and I'll just hit it like this. That'll get me, see, that's getting me up there real quick. And what? There it is. Can you tell where that is? I can't tell either. Menu 6, 4, and if I do it like this. Oh, so it's going to take 55.7 years. All right, so 55.7 equals T. 55.7. 55.7. So let's see. I got to find 1954 plus 55.7. That's 9. That's 0, 0. So 2009.7, almost to around 2010 is when it when herd reached 25 million head. All right. Now, oh, we're not done. We're not done. We're not done. Let's see here. We get this exponential growth. It was growing, so that's exponential growth is 1 plus r equals e to the 0.154. Oh, so I have to do some of that magic. R equals -1 plus e to the 0.154. Oh, man. So R equals, let's see here. Let's get here. And we got -1 plus e, and I got times. I don't want times. I said plus e, and at 0.154. And I'm getting 0.1665. 0.1665. So we have a 16.65% growth rate. Growth rate. All right. Good job, folks. See you in class tomorrow or whenever we get to go back. And y'all have a wonderful evening.